I'm sure, maybe a couple more people will join us here in a minute, and that's fine. But just wanted to go through a couple little business items, just little reminders for you. If you are going to the Denver Museum of Nature and Science, really cool deal that we got. We get to go into the Pompeii exhibit, the planetarium, and the whole entire museum for only $10 per person. That is like way cheaper than you'll ever get it by yourself. Um, so hopefully you guys can all show up, and that's actually next Tuesday. We're gonna meet at 1 p.m. And that's when we'll collect the money, and we'll just collect the money all as one group, and then pay, and then I'll divide some kids up because we're gonna kind of split up and do things at different times. So anyway, very cool day. So I'm looking forward to it. And then just a little side note here about your interim tests. Hopefully you've all had a chance to complete them and scan in your written responses. This is from a couple days ago, so it could have changed. But so far I had Christian and Kaylee. Did you guys finish those last night? Okay, good. So I'll take you off my list. Um, let's see, who else is sixth grade? Let's see, Jack, I just emailed your mom and gave her the hard copies so that you can print out your written responses. Looks like Tyler is good. And I think that's it for sixth grade. All right, perfect. Yay. Okay, guys, we'll go ahead and get started with some practice problems. But first, have we come across any examples of math in real life in the last few weeks? Things that you have experienced? I'll just give you one example. Like today, I had the final cost for our field trip. So then I divided the cost by the number of people attending, or the number of people who at least RSVP'd and said they were attending. So that was an example of math. Yeah, Kaylee.
I was making cookies and I had to double the recipe.
Mmm. Are you going to bring me some cookies? Double the
Maybe.
recipe. So she had to do things like probably add. She probably had to add mixed numbers because we know that when you're using a recipe, it's never just an easy. Everything is just 1 cup. Sometimes it's like 1 3/4 cups, and you have to add that up. So that's really good. All right, guys. So the skills that you've been working on or will be working on soon are things like equivalent fractions, mixed numbers, kind of converting between, I should say, mixed numbers and improper fractions. So changing those. Greatest common factor, and then, of course, lowest terms. So we're going to practice with those skills. And then some of you might already started, but this is going to be for next week. You're going to be converting fractions to decimals. So we'll do a little bit of just a preview of that. And then if we have extra time, we still have our game that we could go back to, and hopefully we didn't memorize the answers and we could play again. But all right, are we ready to get started? Give me a thumbs up. Yay! All right. So let's just start. Oops. I thought I had wiped this board clean, and I guess I hadn't. Sorry. There we go. So let's just start with a little review of what you've been doing with proper and improper fractions. So here's a couple examples of proper fractions. Who can tell me what makes these proper fractions that I don't need to do anything more with them and they are just done? What makes them proper? Tyler.
What makes them proper is that it's not a whole number, and the numerator is not larger than the denominator.
That's right. Numerator, remember, are the numbers on top, and you can tell that they are all smaller than the denominators. And not only are they smaller than the denominators, these cannot be reduced any farther. They are in their smallest form. They are good to go. So those are pretty easy to work with. But then sometimes you start getting into improper fractions. And I bet you can guess what makes these improper, but let me just show you some examples. 7/5 is improper, 12/7, 16/13. What makes these improper fractions? Kaylee P. Your microphone's on my end, so make sure that yours is on, and then you can go ahead and tell us. Oh, very strange. I'm not seeing your microphone. Um, in your control panel, Kaylee, if you push the audio button, there's like a little triangle that says audio. Click on mic and speakers. And hopefully that'll turn it on for you. So I'll give you a second to do that. And in the meantime, does somebody else want to tell me what makes these improper? I think it's working now, Kaylee. Go ahead.
I mean, no, the top numbers are larger than the bottom, and they can be reduced more.
That's right. So the top numbers are obviously, or I should say, let's use the correct terms. The numerators are bigger than the denominators, and these need to be turned into something called mixed numbers. So, does anybody remember from your lesson last week how to convert an improper fraction into a mixed number? So let me wipe this clean, and then let's just take this very first example. And Will, I want to turn this into a mixed number. So what should I do? Not Will, I'm sorry, Jack.
Yeah,
You're on your brother's computer, but
yeah, that's all right. Um, so you see how many times 5 goes into 7?
that's right. It's a division problem. Basically, you're going to see how many times 5 goes into 7, and then what is left over becomes the rest of your fraction. So, how many groups of 5 fit into 7?
1,
1. And then what's left over?
3.
2, right?
Oh, yes, sorry, my bad.
That's okay. So your improper fraction, I'm sorry, your mixed number would be 1 2/5. Now, there's something that I used to talk about in the regular classroom, and I'm going to try to show you on the screen the best I can. It's called magic circle time. Woo! Magic circle. If you want to check your work to make sure that you have converted these properly, do the magic circle. So basically, you're going to multiply 5 times 1, and then you're going to add, and we'll see what we get. So everybody, what's 5 times 1? 5 plus 2, 7, and then you just keep your same denominator. So yes, that is a way to check your work, that you have converted between your improper fraction and your mixed number correctly. Okay? So let's try another one. And we could do a magic circle. It'll be kind of fun. But let's go back to that one improper fraction that we had of 12/7. I want to change this into a mixed number. So I'm going to say to myself, how many groups of 7 fit into 12? And then what's going to be left over? So everybody hold up your fingers. How many groups of 7 will fit into a 12? Just one. And then what's 12 minus 7? 5. Good. So then I just have the same exact denominator, and it becomes 1 5/7. So let's do magic circle time. Woo! It's not quite the same on the virtual classroom screen, but whatever. All right, so let's multiply. 7 times 1 is 7, and then 7 plus 5 is 12. Keep your same denominator, and what do you know? You did it correctly. Perfect. Give me a thumbs up if this is making sense. Pretty easy. We'll do one more before we move on because this is pretty basic, but this one's maybe slightly harder. I don't know. 16/13. I need to change this to a mixed number. So everyone, by show of fingers, how many groups of 13 fit into 16? Only one. And then 16 minus 13 is 3. And I just keep my same denominator. So let's check my work. Woo! Magic circle. 13 times 1 is 13, plus 3 is 16. Keep that same denominator, and what do you know? You did it right. All right, guys, we will move on from this because that is pretty easy. Okay, so let's go to, let's go to 6th grade. And we have a little bit of review to do with a little bit more with fractions and mixed numbers. And then we also covered equivalent fractions, so we can talk about that. But then I also want to spend a little bit of time with simplifying fractions, which I'm not sure how much they've shown you. Actually, I don't think they really have, but this is a huge skill. And for instance, if you take like your CSAP test or really any test, and you do not simplify your fraction to the very lowest format, you'll get the problem wrong. And it's kind of sad. So, all right, let's do, and you're going to be typing into your chat a quick little review. What fraction does the number line show? So you're going to type in whatever, and then that slash button, which is on the bottom of your screen where your question mark is, and that's how you'll show your fraction. Good, Tyler. This one was easy. This is the fraction 3/4. Okay? Here we go. What fraction of the balloons are orange? Go ahead and type it into your chat. Very good. 2/5. 2 out of 5. Perfect. All right, what fraction does this number line show? They divided it up into 5 different blocks, and yes, 3/5. Woo! Whoops, sorry. All right, this one's easy. What fraction of the cars is yellow? All right. Way too simple. We're going to go on.
What was that buzzing noise?
Hopefully, if we have a little bit of time, too, I can go to the 7th grade math and we can look at some of their fractions. Okay, here we go. Equivalent fractions. So, equivalent fractions. Let's just stop for a second before we start jumping into it, and we'll just do this one problem together. I'm looking at, basically, I could just call this an x, and then over 13 equals 24/39. I have to figure out, and this is how I always think about it, what do I have to do to this 13 to get to 39? And that's the same thing I'm going to do to this, whatever it is, to get to 24. So, what do I have to do to a 13 to turn it into a 39? Maybe multiply it by something? I'm going to take a screenshot of this, so just bear with me a second. Good. Yes, I'm seeing in the chat everybody is telling me to to turn a 13 into a 39, I'd have to multiply 13 times 3. So in fractions, whatever you do to the bottom, you do to the top, and whatever you do to the top, you have to do to the bottom. So basically, I'm going to have to multiply some number times 3 to equal 24. So what number times 3 equals 24? 8. Perfect. Now I could check my work. 13 times 3 equals 39. 8 times 3 equals 24, and I am set. Okay, perfect. All right, here we go. 28/35, this is reducing fractions, which I like better, equals x over 5. So what do I have to do to a 35 to make it a 5? I have to divide by 7. So 35 divided by 7 equals 5. 28 divided by 7 equals 4. And everybody's saying 4/5 is the answer, and you've got it. This is too easy. You guys are just like advanced or something. 2/18 equals, oh, this is simple. To turn an 18 into a 9, I have to divide by 2. So what's 2 divided by 2? 1. Oh my gosh. All right, maybe it'll get a little harder. 40/50 equals, well, to turn a 25 into a 50 into a 25, I have to divide by 2. So what's 40 divided by 2? 20. All right, good job. I'm not going to spend any more time on this because I'm seeing in the chat and just by everybody's answers that you have got it correct. So, equivalent fractions. Woohoo! Let's play a little equivalent fraction game. Hopefully it'll be a little harder. And then we'll go back to greatest common factor in lowest terms. Okay, so this is a matching game. I'm gonna flip over a card and then I'll flip over another card. And what we're trying to do is find the equivalent fractions. So I have to flip over 2 equivalent fractions. So I'll just start by flipping over this one. It's kind of like memory. Okay. Nope, those aren't equivalent. So hopefully it's a game of memory. Ooh, did anybody see an equivalent fraction to 1/2? Kaylee P.
It's the 3/6.
Perfect. All right, so I got one pair. 4/12, 7/8. Nope, those aren't equivalent. 12/20. And if you see an equivalent fraction that, I have flipped over one of the other cards that's equivalent, raise your hand and then, just tell me which card you want me to flip over. 6/9. Nope. Ooh, 18/60. I don't know. We might have seen. Nope. 35/40. Anything yet? Nope. 30/40. Nope. Okay. 12/20. See, this is a little harder. This is good. Anything equivalent that you remember yet? Not yet, huh? Okay. Oh, 3/18. Kaylee P, did you see a match?
6/9.
Yes, 6/9. Perfect.
6/9.
Oh, whoops, did I click on the wrong one? Oh, those aren't equivalent. Wait a minute, why not? 3/18. Oh, I'm sorry. Okay. Yeah. Yes, because 3 times 2 and yeah. All right. So that was a little tricky. Ooh. 4/12. I know this is tough. I'm just gonna start like clicking on the same one over and over. Tyler, have you seen a match yet?
The 1/6 next to half, and then 3/18.
Okay. Where was 1/6? I don't even remember. Was it this
Right
one?
next to half.
Okay. And
And
then
then 3/18.
is it
I
this
think
one?
it I think it was two to the left.
Yay! Perfect. Okay, so at least we got one more match. All right. 30/40ths. Is there a card I haven't turned over yet? Probably is. 5/20ths. So that's equivalent to 1/4. I haven't seen that yet. Ooh, 2/3. Okay. Oh, there's 3/4. Kaylee, did you find a match?
On the most left one, 3/4, um, do the third one to the bottom.
Third one to the bottom. So this one?
Move one over.
This way?
Yep.
12/20ths and 3/4. Not quite, but that's okay. Memory's hard. It's Jack. Yeah, sorry. Did you find a match?
Yeah, it was a 3/4 and 3/4 and the one right under the 3/6.
Okay, so let's try. I'll do that. I have to flip over these cards. Let's see. Yes, 3/4 is the same thing as 30/40ths because I could just get rid of both of those zeros, and there we go. Perfect. 4/12. Ooh, where was that 1/3? Tyler?
I was just about to say that one, and then all the way at the bottom on the all the way to the left.
Yeah, I think that was the 1/3. Perfect. Okay. Is there another match that you knew of, Tyler?
It was, I think, in between 4/12 and 1/6,
Okay.
and then all the way at the bottom right.
No, not quite. That's all right. 6/9. No. Man, memory's hard for me. I'm not remembering where any of these are. Does anyone remember where 1/5 was? Because that would be the equivalent fraction of 4/20ths. Let's take a guess. Was it here? No. Ah, there's 1/4. Nope. There's 3/5. Tyler, do you remember where a match was?
Under 3/4
Okay.
and under 1/2.
Perfect. Yay. Okay. Now we're getting somewhere. Kaylee S.
Under 4/12 and under 3/40, 30/40.
There we go. Perfect. Okay. It should be a little easier now. Ooh, 7/8. Where was that 35/40ths? Jack, do you remember where that one was?
The bottom right.
Bottom right? Perfect. Yep, 35/40ths and 7/8. Good. 18/60ths. Oh gosh, I don't remember. Let's just try this one. Nope. Okay, I was looking for that 1/5 earlier. Ah, 2/3. Okay. Oh, here we go. I remembered one. No, wait. Yes. Okay, got it. All right. So now, all right, Tyler.
I think it was the one all the way on the top row,
Okay.
and then um 2 down all the way on the right.
6/9. Not quite. 2/3 is the same though as 6/9. So that was that one. And then obviously 18/60ths and 3/10. Woo! That was hard. Okay. That woke up a different part of my brain. I don't know about you, but all right. That was pretty fun. Okay, so we've done a little bit now with equivalent fractions. And actually, just by going back to this, if we look at it, we can see that, something like 30/40ths, it's just really easy to reduce it. If I divided both 30 and both 40 by 10, then I'm going to get my smallest fraction possible, or simplest form, which would be 3/4. Something like 35/40ths. If I divide both numbers by 5, I'm going to get my simplest form, which is 7/8. And so that kind of leads into greatest common factor talk, because if I divide 35 and 40 by their greatest common factor, I'm going to immediately get the simplest form. And that's easier to do than, like 3 different division problems. So let's just go ahead and write these down. Let me pull up my screen and clear this. Okay, so I want to find the greatest common factor for 14/21. So this fraction can be reduced quite a bit. So I need to list the factors of 14, which would be 1, 2, 7, and 14. And then I would come down below and I would list the factors of 21. 1, 3, 7, and 21. What is the greatest common factor that they both share? 7, right? Good. So now if I divide 14 and 21 both by 7, I'm going to get simplest form. So what would my new fraction be? 2/3. Perfect. Give me a thumbs up if that made sense. Okay, greatest common factor. Not too difficult. Let's try another one, and I won't do this one for you. What if I have the fraction 32/44? I want to reduce it, so I need to find the greatest common factor that they both share, and then divide so that I can get the simplest form. So go ahead and make your list of your factors for 32, and then a list of your factors for 44, and let me know when you find the greatest one that they share. Keely S. is like, you know what? I'm just going to go ahead and solve it. And that's good. All right. So what is the greatest common factor that both 32 and 44 share? You can hold up your fingers. Okay, 4. So if I divide 32 by 4, I get what? 8. And then if I divide 44 by 4, I get 11. So my simplest form is 8/11. Perfect. All right, guys, that was pretty simple. One more. Okay, I have the fraction 30/48. First thing I want to do is list the factors for 30, list the factors for 48, find the greatest common factor, and then I need to make this fraction simplest form. Okay, who wants to tell me what the greatest common factor for 30 and 48 is? Kaylee P.
Um,
I'm sorry, you cut out. What was it?
6.
That's right. So I'm going to divide both the top and the bottom by 6. Because remember, what you do to the top, you always have to do to the bottom. So 30 divided by 6 is 5. 48 divided by 6, everyone? 8. Okay, 5/8. All right, perfect. Let's go on to a couple more problems on here. Okay, there's several. Give me just a second here to find where we were at. Here we are. Okay. All right, here we go. Let's do a couple more practice problems and then we'll move on. We can maybe do a review of our game and then we'll actually preview next week's lesson as well. So, write 31/3 as a mixed number. Go ahead and just type this into your chat. Review from about 15 minutes ago. Good, Tyler. You can make it a private chat to me so no one else sees it. Very good. By doing magic circle time, very easy to check your answer. But, oh, sorry. Just type in 10 and 1/3. And there we go. Perfect. Write 11/7 as a mixed number. Just a little check to make sure that it all made sense to you earlier. Okay, I'm getting one answer. Got 2. 1 and 4/7. All right, you guys are good. Easy. All right, well then, you know what? Let's start previewing next week's stuff so that maybe we'll have a little time to play our game. Okay, so when you are converting fractions to decimals, and you have a fraction like 6/100, or a fraction like 3/10, or a fraction like this that looks more complicated but really isn't, 444 thousandths. Just because you have 100 or a 10 or 1,000 in the bottom, it's really easy to just write it out as a decimal. Just say it to yourself, 6/100. You'd come over here. You know that this is the 10ths position, this is the 100ths position, and there you go, 6/100. Pretty simple. 3/10, even more simple. Here's the 10ths position, 3/10. 445 thousandths, also simple. You know that this is the 10ths, hundredths, thousandths. Well, there you go, 445 thousandths. So when you have a 10 or 100 or 1,000 on the bottom, it should be really simple for you to convert those. But sometimes it's going to be a little more complicated. We'll start kind of simple because this is probably one that you have memorized. And you're going to notice that there's not a 10 or a 100 on the bottom, so maybe it's a little bit more difficult for you. Yeah, go ahead, Tyler.
Can't you reduce 445 1,000ths? by 5.
Yeah, you could have, but I mean, we were just simply writing it as a decimal, and so we just wrote it, I mean, word for word. If it's 445 thousandths, I just converted it right into a decimal format, which is tens, hundredths, thousands, and I don't need to go any farther. So, yeah. But when I'm working with numbers like 3/4 and I'm like, oh no, I don't know exactly what the equivalent decimal is. Well, there's several that you're going to probably just memorize as time goes on. Things like 3/4 should start, becoming automatic to you, that that's the same as 75 hundredths or 0.75. Same with, really easy fractions like 1/2. You should just recognize and, I mean, just by memory, know that 0.5 is the same thing. Another really common one is 1/5. You should just recognize in your head that zero point 0.2 or 0.20 is the same equivalent as 1/5. Um, I could take this even a step farther and show you how I went from fractions to decimals to percents. To take it to a percent, even though you're not doing this yet, but it's just good future knowledge for you. All I would have to do is multiply this by 100 or move my decimal over 2 places, and what do you know? It's 75%. Move my decimal over 2 places because I multiplied by 100, and what do you know? It's the same thing as 50%. Move my decimal over 2 places, and that's the same thing as 20%. So these are really common, and you should probably just start committing them to memory right now. Let's do a couple more common ones before we make it more complex. Another common one is 2/3. Okay. Does anybody want to take a guess at what that is in decimal format? Maybe you just recognize it. Tyler?
It's 66 repeated decimal.
Repeated. Yes, exactly. So that's kind of the same thing as like saying 66%. Very good. So these are just really common. But let's say that you were looking at 2/3 and I had no idea how to turn that into a decimal. Fractions are just division problems, guys. So all you really need to do is take your numerator, put it underneath the house, take your denominator, put it outside your house. You're going to have to add a decimal, and you're going to have to add a 0 in order to do the problem. Gosh, that's sloppy. Sorry. So now, how many groups of 3 fit into 20? 6. Simple division problem. And they would just repeat on and on and on forever. So give me a thumbs up if that's making sense for you so far. Yes, good. Fractions are just division problems. But things like 2/3, you're going to just start to recognize without even having to do the division problem. Okay. Trying to think of another really common. Oh, here's another common fraction. Maybe not as common, but 5/8. Well, let's say that you don't know right off the top of your head what the decimal equivalent is. So come over here, turn it into a division problem, put your numerator under the house, put your denominator outside the house, add your decimal and your 0, because you wouldn't be able to do the problem otherwise. And then, how many groups of 8 fit into 50? Anyone? Okay, I'm seeing a 6. What's 6 times 8? Good. What's 50 minus 48? There we go. And then 8 divided by 20. Anyone? 8 divided by 20? or 20 divided by 8, I should say. Tyler?
It's 16 and it's divided by 8 goes into 20 twice and you get 16.
Right, yes. There you go. Okay, and then one more time. How many groups of 8 fit into 40? 5, and then I'm done. So here would be the decimal format. And let's say I wanted to make that a percent. All I would do is multiply it by 100 or move my decimal place over 2 places, and that's 62.5%. Okay? All right. Yes, Tyler.
Oh, I was stretching.
Oh, you were stretching. Okay. Woo! Let's see if we have some other problems like that we can practice. All right, so we are taking fractions and converting them to decimals. Let's see. This might be, oh wait, no, nope. I might have to move up to the 7th grade stuff to find some problems. Huh, that's all right, I guess. Wow. Doot, doot, doot. You guys caught on to that faster than I expected, so let's see. Convert decimals, nope. Okay. I'll search for 1 second, and then if not, we'll just go on to our game. All right, let's look at decimals and see if we can find anything with converting fractions to decimals. I guess I should have gone to fractions, huh? If anybody sees it, let me know. Oh, here we go. Yay. All right, so this is a little skill that we, haven't necessarily done yet either, but it will be coming up in your future, so it's not a bad thing. So write 6.6 as a mixed number in simplest form. So read it to yourself the correct way. That is 6 and 6/10. So how do I write 6 and 6/10? You write it like this: 6 and 6/10. That is not in simplest form because 6/10 can be reduced. The greatest common factor of a 6 and a 10 is what? Greatest common factor they both share is 2, right? So this would be, what's 6 divided by 2? And yep, 10 divided by 2. Perfect. So that would be the way that you would reduce it. So don't let that trick you. 6.6, how do I write it as a mixed number? You just read it the correct way, and then you're able to write it the correct way. 6 and 6/10 is not that hard to write. 6.6 is a little bit harder to think about, but okay. 2/10 as a fraction in simplest form. So write it the correct way, 2/10. 2/10 is written 2/10. Greatest common factor they both share is 2, so this should be pretty easy. Yes, 1/5. And just a little FYI, here's one of those fractions and decimals that you should just start to recognize. Okay? Just start to memorize those. All right. Oops. Oh, sorry. There we go. All right. 4 and 25/100 as a mixed number in simplest form. So just say it to yourself. 4 and 25/100. Okay, now you can reduce it. Greatest common factor they both share is 25. Perfect. 4 1/4. You guys are getting this. Yay! All right. Man, my throat is dry, so I'm going to do a little less talking, and we're going to go on to our game. So this is a review from a few weeks ago, but that's never a bad thing to kind of just see if we remember what we had done. So let's see. We have Kaylee, Ashley, Jack. How many teams here? We have 1, 2, 3, 4, 5. And then in the chat, we have Christian, 6, and TJ, 7. Okay. So, team 1 is Kaylee S. Team 2, Kaylee P. Oh, that's going to confuse me, but whatever. Ashley, team 3. Jack, team 4. Tyler, team 5. Christian, team 6. And TJ, you can be team 7. And if you'd like to type into the chat when you have an answer, I'll take your answer that way. Okay, my imaginary dice says that I rolled, and Ashley, or team 3, is first. Which category would you like, Ashley?
Challenge for 200.
Okay. How do I write the equation any number decreased by 7? Jack.
X minus 7.
That's correct. All right, Jack, yay. Pick a question for us.
Decimal patterns for 100.
Okay. The product of 32 and 5/10 times 10. Kaylee P.
325.
That's correct. You just move your decimal place over one spot because there's only 1 0 here. And you are team 2. Okay. All right, Kaylee.
Decimal patterns for 300.
All right. The product of 74 and 98 hundredths times 10. Kaylee S.
749.8.
That's right. Good job. Yep, you just moved your decimal over one spot. Okay, Kaylee S.
Decimal patterns for 300.
Woo, you guys are on a roll, huh? Oh. Tyler. So your challenge is going to be to read this.
56,789.
And 8/10.
Yeah.
Okay. All right, I'll give it to you. Good, and TJ got it too. Tyler, what team are you? 5?
5.
Okay, there we go. All right, Tyler, choose a question.
Challenge 300.
All right. How do I write 8 times a number? Ashley.
8 times B.
Yeah. Or N, or X, or whatever you want it to be. Perfect. Okay, Ashley, choose one for us.
Decimals by decimals for 200.
Oh, all right. So that means multiply. Ooh, the product of 5/10 times 1/10. This is a sort of trick question. Christian.
5/10.
Actually, before I give you the correct answer, just here's a little review for you. In your problem, there's 1, 2 digits after the decimals. So in your answer, I'm going to have 2 digits after the decimal. So it's going to end up being actually what, Tyler?
500ths.
500ths, right. Very good. And TJ got it too. Perfect. Okay. Tyler, choose one.
Challenge 400.
All right. Scroll over here. How do I write a number divided by 13? Jack.
B B divided by 13.
Perfect. Yeah, or N or X or whatever. All right, Jack, you're team 4. And I saw TJ is really fast in the chat. He got it too. Good. All right, Jack, choose a question for us.
Decimal patterns for 500.
All right, we like those decimal patterns because they're somewhat easy. Did you say 500 or 400?
500.
All right. Woo! The challenge will be to read the number correctly. Kaylee P.
Um,
You can write it down.
234,000, 800 and, wait, no, 200, 2,348,900, oh, sorry.
How about you start with 2 million? Like this.
2 mil,
Yeah.
sorry.
I know you know where to put your decimal because it's really simple to see that there are, 4 zeros. So you're just going to move your decimal place over 4 times. Reading the actual number is the hard part. So now try it. 2 million.
$348,993.4.
That's right. And let's try to get out of the habit of saying 0.4 and stuff. Say like 4/10, because that will help you in these coming units with, writing fractions correctly. So, all right, let's do estimating products with decimals for like 500, because this will probably have to be our last question. Round to the largest place value and then multiply. So is this closer to 2,000 or 3,000? And is this closer to 5 or a 4? Okay, Jack.
Hang on. 10,000.
That might be a little high because 2,345 is closer to, and good job, Christian, you got it, is closer to 2,000, and then this is closer to 4. So 2,000 times 4 is 8,000. But you guys did fantastic today, and this has been a lot of fun. Hopefully we'll have more time, and I'll make more Jeopardy games in the future. But you guys just blew me away on these fractions and equivalent fractions and greatest common factors. You know your stuff. So good work, and I guess I will see most of you on Monday. Don't forget to check your email. That paragraph that you're going to be, and this applies to everybody, the paragraph that you are writing for your final book club assignment, you're going to type it into the same Google document. So you're just going to, type it right underneath mine. And then if you see Jack's paragraph, you'll type it right underneath his, and so on. So, all right. And Tyler, you have about 1 minute, but the rest of you are ready to go. So I will see you next time. Bye. Okay, Tyler, you're the only one. Here, let me stop the recording right quick.